And good evening, everybody. Welcome to this webinar entitled A Deep Dive. We're going to explore GeoGebra's graphing calculator and geometry apps here within the hour. Now, we're not going to discover everything there is to know about these two apps in the hour that we have. So this is probably going to be a part one of maybe two, three, four. I honestly don't know. I mean, come on. How many of you teachers have had students engaged in a lesson and they didn't actually learn as much as you thought they would? So what do? You kind of stop it and then you kind of pick up the next day. So it's same logic here. So I welcome you. If this is your first time to exploring GeoGebra, checking out what it's about, I welcome you. My name is Tim Brzezinski. I'm the Professional Development Director at GeoGebra. Prior to that, I was a full-time independent math ed consultant for about 2.5 years. And before that, I taught high school math 15 years at Berlin High School here in my home state of Connecticut. And honestly, all throughout my teaching career, my passion, if I could sum it up in 6 words, was active, student-centered, discovery-based learning. That's it. No more, no less. I want to create learning environments where kids are excited and engaged to explore and learn about the world of mathematics around them. That's my passion. That's my heart's goal. All right. And I've used many EdTech apps. I mean, each app does what it does well. So, my favorite happens to be GeoGebra because I have personally found that there's nothing that it cannot do. But here I'm here to show you 2 apps, Graphing Calculator and Geometry, just to explore these apps and how we could use them pedagogically to foster student-centered learning while we simultaneously learn how to actually use the apps themselves. All right. So I'm going to share my screen. We are going to rock and roll here, and there we go. So welcome everybody. I love seeing the comments there from all over. Thank you. So here's GeoGebra's main page. It's geogebra.org, geogebra.org, and this is home. This is home base right here for GeoGebra. This is a screen that many of you who have been to GeoGebra are familiar with. And at the moment, if you do not have a GeoGebra account, I'm going to ask you to take the next minute to please make one at this time. To do so, you'll need to go up here in the upper right corner where you see my mugshot. You'll see the word sign in right up here. And if you could please take a moment to sign in and create an account, that would be great, because we're going to create some constructions here and I'm going to want you to save those constructions should you want to go back to them, say. Okay, so obviously you need an account in order to save your work as well as your students. Okay, for what we're doing tonight. Now, I know there is a workaround that I don't have time to explain right now, but I can provide a link later where teachers tell me, Tim, my district administrators won't let me have my students create their own GeoGebra accounts because they're either under age 14 or because whatever, the district has its own regulations. I get that. There is a workaround right now through Google Classroom. I have a 5-minute YouTube video on that I could drop you a link to later. But yeah. So in the meantime, if you could just create the GeoGebra account, you as a teacher can obviously have one. So let's do that. And so once you are signed in, you should see a letter up here where I have a picture. So yeah, but just as a quick announcement, GeoGebra recently put these 4 icons right here, these 4 thumbnails right at the top of their page. If you're an elementary school teacher, middle, high school, all right. There are over 2,000 resources in these 3 activity pages here that you could use readily to foster active student-centered discovery learning. Okay. Now, these are resources. These are a compilation of activities that many of the international community have created using GeoGebra's apps, and they are available to you, the public. See, GeoGebra is all about community. It always has been, and it always will be. It's a community of sharing. All right. Now, I have learned from so many people on GeoGebra personally, and there's still a lot that I personally don't know. But you know what? If I don't know how somebody made something, I open it up in the app and I kind of look behind the scenes to see what the heck is going on here. All right. And I'll show you how to do the same in a little bit. But right here where we're gonna play around is right here. So I'm gonna go to the upper squares here. All right. We're not gonna look at resources tonight. We're gonna look at apps. And the 2 we're going to explore are the graphing calculator and geometry. Okay, now we're in a series right now with 3D Calculator. We did parts 1 and 2. We're going to start part 3 next week. You're more than welcome to join then as well. And we'll do some webinars on the CAS maybe in a month or so. But right now, the most popular the most popular app that's actually used is the Classic. And many of you longtime users of GeoGebra know that the Classic app is a big, huge app with many different perspectives, like 2D, three-dimensional. There's a spreadsheet in there. There's a probability and statistics calculator. It's a huge package, right? And it's a lot. But if all you need is a simple graphing calculator or a palette where you can do geometric constructions and perhaps play around, the geometry app is ideal for you. Okay, so what we're going to do is we're going to first explore the graphing calculator. So if we can go ahead and click on the graphing calculator icon, we'll do just that. Now, hey, newsflash, all right, this pops up, and this actually took many people by surprise about on February 6th. Many people were kind of shocked, and there were a few that were actually quite upset, actually, to find out that GeoGebra actually removed all the geometric construction features from their graphing calculator. And and basically the reason why they did this is so that they could have one single app that was now exam compliant with many districts and state departments of education here in the US and in other parts of the world. So just to show you what I mean here really quickly is that if you actually go to now in any of the two apps we're working in, here we're in the graphing calculator, this is the algebra view. All right, so when I refer to algebra view, no, I'm talking about the calculator here. Okay, now there's the tools that are right here. There's basic tools, right? So we could plot points, do a line of best fit, get extrema roots, all that, right? But the reality is that there's not a lot of tools in this graphing calculator. Now there used to be prior to February 6th, but in order to be exam compliant, let's suppose I just plot 2 points right here, right? Point A, for example, is at 2, 3, and point B is at what, 7, 6, right? Now, if I try typing the midpoint command, right? GeoGebra says, hey, can't do it because there's no, this tool is unknown here, right? Because many exam bodies expect the student to be able to find that midpoint algebraically. Okay, now granted, this does not address many governing bodies, because there are countries, say in Europe, for example, where they assume that CAS technology exists, and so their exams are much different than a lot of the exams, say here in the United States, perhaps. Again, I'm not saying one is right, one's wrong, but the point is, in order to have a calculator or an app that is exam compliant, right? With think of this app as a TI Inspire in full-blown exam mode. There's a lot of functionality that is shut off, right? So that's how it works. Another example, let's suppose I want to graph a circle. Now the circle with center through point tool used to be here, right? But it's no longer here. So if I'm expected to know how to write the equation of a circle, say centered at 0, 0, whose radius is, I don't know, 3, I actually have to type the equation, all right? So the radius is 3, so it'd be what? X squared plus y squared equals 9. And there you go. Now see, there's no other way I can make that circle appear without knowing its equation. Now in the other app, the geometry app, that is not necessary. There's a circle tool, you just plot it and boom, there you go. The equation will pop up if you ask it to, okay? But this graphing calculator is an app that is exam compliant. And GeoGebra makes this statement that if you know someone who is in a higher up State Department of Ed, you know what, this graphing calculator is absolutely free to embed, literally free for any governing education body, any State Department of Education, any Ministry of Education can use this app free of charge, as long as it's for the purposes of assessment. Okay, so with that said, but nonetheless, even though there's a lot more power in the geometry app, which we're going to explore in the next half hour, we could still discover a lot here, even though there's limited function, even though the geometric construction features are removed. And I'll give you a couple of examples here. But first, I want to start with just absolute basics, right? Now, if you are on an iPad or on a phone, for example, there is a native app to the phone, the iPhone and the Android. But right here, down in the lower left corner, you'll see a little keyboard. If you touch it, right, it'll pop up, and you could type commands in here. Ideal if you have a touchpad. All right. Now you could type with the keyboard right here, of course, right? But you might miss a space or do something here. I like to use the keyboard when I can, but obviously this is a calculator, 45 times 63 divided by, notice how it's just changing instantaneously. The more I type, the faster I type, the faster it computes, right? So again, it is a calculator, of course, literally, but also, and by the way, pre-calc and trig teachers, you might find this interesting. If you were to type in the sign of, say, 60, or let me say 30, GeoGebra knows you're talking about degrees, okay? But if you ever throw in a factor that has, throw in an expression that has a pi in it, let's say, for example, the sine of pi divided by 6. Now, again, if you type pi, GeoGebra knows you mean pi. Let's see here, it says 1/2, and actually change it to pi right there. So anytime you type in pi as a factor of a monomial term that's, or whatever that's in here, GeoGebra assumes radian mode. So there's no more of that, oh crap, was the calculator in the right mode? You know what I mean? It just knows. By the way, the pi key is right here, down below there. But anyway, it's a calculator, of course. But we can also do basic things like think of what you do on a typical TI or Hewlett Packard or one of those Casio, the handheld calculators, right? What do? You graph functions, right? So let me type in a quadratic, x squared, say minus 5x, I don't know, minus 1. Notice I didn't type in y equals. All I typed in was an algebraic expression. That's all I need to type. So whenever you just type in an expression in terms of x, you hit enter, GeoGebra will call it a function. And so there's your parabola, your quadratic function there. And notice right here, those gray dots that appear. If I touch it, obviously, I can get the roots rather quickly. The y-intercept, which should be obvious, and any relative extrema. Okay. Now, what else? Now let's think of a function that has infinitely many extrema. Right, I would ask it on the YouTube thing, but there's a 10-second delay. But let's say a sinusoidal curve, sine of 2x minus 3, right? Or sine of just 2x minus, I don't know, 0.4 or whatever. So there you go. But any one of these, how long would it take you to get these values on a handheld? Yeah, you don't have to answer that. It'll take forever, right? But here, it's quick, it's easy to use, painless, okay? And again, right here, just kind of looking through here, because I could find this point of intersection even right here. Or if I were to actually type the circle x squared plus y squared equals, say, 9, right? I can actually see where that quadratic and that circle approximately intersect, okay? Again, very easy to use, very user-friendly, in my opinion. So now, if you ever want to delete something, you just simply go to the snowman right here, the 3 dots, so you can delete it, okay? And yes, Sam, it does assume radians for graphing when graphing a trig function, provided that well, it depends here. Let's graph another trig function here. Actually, yes, Sam, it does. I'm sorry, a little late here for me, but yes, it does assume radians. But right now, we could take anything that we make, and we can actually just go ahead and make a table of values for it. So we'll start at negative. Let's say start at 0. Let's go to 100. We can go by 2s. I don't know, whatever you want to do, right? And there it is. There's your table rather quickly. Now, notice if I zoom out here, notice, let me actually put a better function in here. Let's just do 1/2 x minus 1, right? Notice when I make my table of values, GeoGebra also plots in a sequence of points, which I think is kind of cool because you can actually take this now, you can hide it and actually see, whatever, it is what it is. But it's pretty cool, right? Now, let's actually talk about how to use this app for one instance of using this app for discovery learning, okay? Now, oftentimes when we teach regression, say, linear regression, popular topic in many Algebra 1 courses, okay? You often will have students plot a bunch of data on a handheld, and then we kind of talk students through it, and we tell them what each of the parameters often mean. But my question to teachers is there a way we can actually somehow use technology to flip it and put it back on the student? Meaning, can I somehow, some way have students figure out what, say, the correlation coefficient actually is and what it does, and what does it tell us? You can. within 5 to 10 minutes. I'm going to show you right here. So what I'm going to do here is I deleted everything, but if we could just go to the tools right here, again, algebra view is here, the tools are here. Okay, let's go to the point tool. And let's just plot, just for the sake of time, let's just plot 5 points. I would often have students plot 8 or 9, but let's just do 5 to make life simple. Okay. Now notice the point tool is still highlighted here. See how it's bold? We need to turn that off. And the way you do that is by hitting the move arrow right down here. You got to turn off that tool because this allows you to drag the points like so. Okay. Now, just a couple other housekeeping items that teachers tend to fall in love with. You can actually change the format of these points in any way you want. Yes, Sam, you totally could. All right, make a graph a trig function. You totally could do that. If I remember, I will show you after. If not, send me an email, tim@geogebra.org, and I will make you a screencast just for you to show you how to do that. All right, but right here, let's actually go to select objects here. That's the select tool. Now, I like to work smart, not hard. All you have to do is draw a box around these points here. Draw a box, and up pops a style bar, right? So I could change the colors of these points. I could change the point size, the point type, X's, pluses, you know what I mean? Again, you do what you need to do there, and you could show the values. You could show the label. Now, many of you probably who are doing this with me probably have 13 digits after each pi because it's rounding pretty generously. So to change the rounding, if you go to the settings gear in the upper right corner, right there, you can just go to settings, hit settings one more time, and there's the rounding right there. And you chemistry teachers will be happy because it could also do the whole sig fig thing too. Okay. Ronaldo with GeoGebra in Classroom. I have look on my YouTube channel, Brzezinski Math. I have it in one of the latest uploaded videos. All right. But it's there. So right here. So let's just keep it at 3 decimal places. Again, if you're projecting on a big screen, you could do like a huge kind of point. I can leave it like that for now. And you could save your settings. You know, when you log in, it saves your preferences, if you will. And pick the language you want. I think there's like 70 something or 83 languages total here. So if you have a student in class whose native language is not the language in the country in which you teach, well, this can be a great accommodation for that student. It's awesome. It's awesome. GeoGebra has a team, believe it or not, GeoGebra has a team of translators that volunteer their time all over the world to help. Again, it's all about community. It's a beautiful community. And I'm proud to be a part of it. I really am. So right here, now let me actually just select these. I don't want to necessarily show the values per se. So I'll just go to the AA and I'll just uncheck value. I just have the points, if you will. Okay. So what we're going to do now is put these points in a list. Again, the goal here is to have the students tell me what correlation coefficient means without me telling them. All right. So I'll give the students directions, maybe written on a sheet, and say, hey, plot 5 points and whatever. And then I'll have them go here to the list command. You see under the points subcategory, there's a green brace 1, 2. Let's click on that. We need to put those points in a list. And the easiest way to do that, is to click on the list tool. And again, I like to call this lassoing all the points. Just lasso these guys. Lasso and let go. And you just put them in a list. And you're scratching your head thinking, wait a minute, Tim, where is the list actually? That doesn't make sense. It's actually in the algebra view right over here in the calculator. You see? If you look here, all of those points we put in the list. And if I ever want to change one of the coordinates, right, I don't have to go to a separate screen where the L1, L2 is. I could just simply go here and change, oops, I made a mistake, and change it right there, if that makes sense. Okay. So, or I could have manually typed this out. There's my list. So now, and I'll ask my students at this point, okay, now you tell me, how do you spell correlation again? And they say, okay, C-O-R-R, right? And it pops up. So if I click on this, it'll autofill. Now, in this parameter, I have to put the list of points. what did GeoGebra call? You could type it in the YouTube chat if you want, but what did GeoGebra call this list? What did it name it? It named it L1 right here. So I'm just going to overwrite it. So L1. Aha, there it is. Okay, enter. And so now here's the question I ask students. So talk about discovery learning in a matter of 2 minutes or less. Here you go. The students plot 5 points. They make a list as we did, and then they get the correlation coefficient, but they don't know what it means right now. So, but notice here, you can actually do, see how the correlation coefficient changes? On a handheld, what would you have to do? You'd have to go to a separate screen and then change one X or Y or multiple values and then go back and see how it looks. But here you can simultaneously and instantaneously see changes between the R value and the points on your screen. And so the task I give students now is to simply pair up with the person next to you, and I want you to make that number as high as possible. I want you to get that A value, whatever the heck that means, get it as big as you possibly can. And then all is silent and the students get to work, right? And so now you math teachers know exactly where I'm going with this, right? What's the highest that the correlation coefficient ever gets? Well, we all know the answer is what? 1. And so now students all over the classroom are having those aha moments, light bulb going off over the head, and say, well, gosh, hey, Sally, Mike, what did you notice? Oh, the correlation coefficient is always 1 when they line up perfectly. Oh, could you go ahead and write that on the board over there, please? Yeah. And so the students are talking with each other. They're talking with me. Again, this is the antithesis of direct lecture where the teacher talks to students. No. GeoGebra is a platform where teachers can day in, day out talk with students and not to them. And that's a beautiful thing. All right. So right here, students make that discovery. We could also discover that it doesn't matter. Wow, look, my line is steeper than yours, but the correlation coefficient was still 1, wasn't it? Right? Yeah. And so now, if there's other students in the room, so if nobody discovered it at this point, my next question would be, hey, can you make that number A as low as possible now? And so then the students all get to work and they say, okay, hang on a second. And so they discover the lowest it ever gets is -1, the highest it gets is 1. And so, and you kind of see what I mean there. All right. And so that's kind of how it works. All right. Let's get rid of D here. So I think there's something on the screen here. But regardless, now it moves fine. Sorry, I don't know what happened there. My computer kind of bugged out. But yeah, and so you see changes. Let's talk about a line of best fit. That's very easy too. It's right here. Best fit line. Click on it. Lasso those points again, and boom, there it is. Done in a half a second. And so right here, I have to turn that tool off. Let me go back. How do I see the equation of that line? Well, you could do one of 2 things. You could go here and show the value. Now, I know some teachers might be upset right now that, yes, I know that standard form. When we do this on a handheld, it comes out in slope-intercept form, which is way more convenient. That change is coming to the graphing calculator. It's just not here yet, maybe in a couple weeks, but they're working on it. But there is a way to get it in the meantime. I'll show you a quick workaround. Very simple, very easy. But you see right here, you could also see it right here as well. Now, let me actually just delete this line for a second. Now, let's do this for right now, because I'm not, let me see here, excuse me. Where'd it go? Let me actually look up something here. I'm going to Google the Jamie Anderson snowboard jump. All right, this was from the Winter Olympics a couple of years ago. Drag that picture, whoop, hang on, let me go to images. You could drag any picture out on your desktop right there. There it is. And watch this. You could take that same picture. Oh, but before I do that, I'm gonna delete everything. Hit the trash can, and you could just simply, like an eraser, it just goes away. Whatever, did I get everything? I think I did, right? Watch this. You could take a picture now and drag it right in. Boom. And now we can play with it all we want. We're gonna do a quadratic regression. Take it, there you go. And now I could take this and let's put B at 50. Whenever you import an image in GeoGebra, it gives you 2 corner points, the lower left and the lower right. But now and I could touch on the picture, by the way, click on it. You could actually go to the teardrop and reduce the opacity. So I can better see. Isn't that awesome? Better see what's going on here. I love that. I totally love that. Now, but let's see here. So now what we're going to do, let's actually build a regression here. So I'm going to go to the point tool and I'm going to plot a bunch of points. Now I've had students work on this picture. They do every one, but to save time, I'll just do a few. Just give me a minute. There we go. That looks good, right? Now, granted, I could go Google some info. I can go research and say, hey, how far was that when Jamie Anderson jumped? How far was that horizontal span? You know, I honestly, don't know, but we could Google it and probably find out. Yes, to answer your question, Sam, entering a table of points literally looks just like this. In fact, to answer your question, Sam, I'll do it right now. It's kind of more tedious. It's much faster to plot it and then just use the list command to just, to drag a rectangle around it and boom, you're done. But if I want to put these in a list, Sam, to answer your question, I have to put the open braces and literally type S, R, Q. So this is what I'm doing right now manually is the equivalent of putting the L1, L2, like say on a TI, if that makes sense. But I don't feel like doing all that typing. But instead, what I want to do is just go here and I could just drag the image down and I'm going to make a list one more time right here. Sorry, my calculator's off here. Where's the list tool? Right here. I'm going to go to the list. And I can just see, I had to get the picture out of the way because I can't include that in the list. But right here, or maybe I could, I honestly don't know. I'm just used to moving it every time. But see, to me, Sam, that's a lot easier and faster. Just my opinion, there actually is a spreadsheet on the Classic app. If you're looking for a spreadsheet to plot points, I would go to GeoGebra Classic at the moment and not the graphing calculator. But quick and easy in the calculator, you can do it that way. But see how it just made it quickly? So now I bring it back. And now let's do a fit. We actually want to use GeoGebra's fit poly command. This is one of my favorite commands in the whole calculator. It's called fit poly. And what you need is to type the name of the list, which I think GeoGebra called L1. And then you have to type in the degree, which for a quadratic, we all know is 2. And there it is. Now, I could scale it. I can move up and down, do whatever. I can click on it. Let's make it really thick and we can make it really shiny. Let's make it a nice yellow or something so it kind of shines through the picture there. See what I mean? But there you have it, folks. There's your quadratic regression. There's your equation. Oh, and by the way, you want to make a table for it? Be my guest. Let's start at 0 and go to, well, we went 0 to 50 here, so let's stop at 50. I don't know, and let's scale by, we can scale by whatever we want. GeoGebra will make a table as long as you want it. Pretty awesome. Very awesome. And yeah, so that's kind of how it looks there. You could have multiple tables on here, of course, as well too. If I did say x minus 1, whatever, right, and just make a table for that. Again, you have 2 tables right here. Again, you can make as many as you want. You could choose to hide the points there for g of x. See, I could show it or hide it like the sequence, if that makes sense. Again, the sky's the limit. And again, if I look at this parabola here and touch on it, might not, let me just hide the line because it's kind of getting messy. Let me actually delete the table. We can delete that, remove it. Go back to the calculator. If I make this, let me put this down here. You'll notice that if you click on it and touch it, you should be able to see roots and extrema right here. There it is. See how it's right near K? There's I know the yellow is kind of hard to see, but there's the vertex. All right, so scale up, scale down, whatever 15 and 45 is to whatever, the highest Jamie Anderson jumped in that jump when they calculated it, we could do kind of a comparison there. All right, pretty cool. All right, pretty nice. Yes. All right, so there you go. All right, and so just again, even though this calculator is limited functionality because the geometric construction features were removed, there's still a lot students can do to discover lots of things. And so one more thing, I know it's 9:30, we should hop onto geometry app, but yeah, well, I'll save what I was going to show some more with this for probably the next session. but that's the graphing calculator, just a couple things in and out. And by the way, one more thing I did want to show you. Let me just refresh it so I can get a brand new graph here. I'm going to, let's say I'm investing those typical compound interest problems, right? Let me just make this bigger. By the way, if you don't like those minor grid lines, you don't have to have them. You could actually take them away, just do major, whatever. We'll talk more about that in the geometry app. But for now, let's suppose I'm just investing $1 million. Yeah, right. $1 million earning, let's say 3% compound interest, compounded daily. You know where I'm going with this, right? And let's say, obviously to the 365X, right? We all expect students to be able to put that on a handheld, right? If they're in a course where we're working with compound, with the, compound interest, say. So, and then how many of you teachers have had an issue with the stinking window on a handheld? And then I like to make it a teachable moment for students, right? Again, but for some classes, it'll take them a good 15 minutes just to get a great window. So how can we sort of work around this? So students will start using their mouse to zoom out and zoom out. Oh, Mr. B, yo, look, I see it. And I'm like, well, yeah, but I mean, really 8,000 years in the past? Come on, man. Like what's going on with that? And so the graph I get is kind of ugly, right? So now, just like on a handheld, there is a zoom fit function, which I'm not going to use yet, but it's right here, zoom to fit, but don't hit it yet. I'm not gonna. But I don't tell kids that to start. But instead, what I like to do is say, to show you a little trick here with the axis pinching. If you hold down the shift key on your keyboard, press down and hold shift, and then go to the positive y-axis. See how that arrow becomes like an arrow looking like going up? You can actually squish it down as long as you're holding the shift key down, like that. Hold it down. Ah, that looks a lot nicer, doesn't it? And so now I could also do the same thing here. I could, as long as I'm holding shift, I can stretch it and compress it horizontally while holding shift. It's pretty nice. Again, GeoGebra is not the only app that allows this, but again, it's pretty cool. A lot of people don't know about it. But then again, the typical question, how long will it take my investment to double, right? And then I could type it in and, oh my gosh, look, 23 years, assuming I just let the money grow naturally and don't do anything with it. All right. Or type in other things. So you see, the conceptual is very powerful here because, again, we all know, right? At least I can speak for teachers in the United States. I can't speak for other countries, but there are going to be students who graduate high school who do not know how to solve an exponential equation using logarithms. Not every student is going to be able to do that, but many more students can work on mathematical modeling, aka writing function models and solving problems like this graphically, which again is a very powerful skill that students need to be able to reason conceptually and solve graphically. All right, so there you have it. All right, but we need to go to the geometry app now. Yep. So let's do this, and so we'll go back to GeoGebra. If you click on the word GeoGebra up here, that'll bring you back to home. Oh, we didn't save a construction yet. We'll do that at the end for the geometry app here. So let's go here, and let's now go to geometry. It's the 9 squares in the corner. Geometry is right here. Let's go there and see what we find. Interesting. Now, when you look at this for the very first time, you notice there's a lot of white space here, right? And you only see like what, 5 or 6, 6 tools right there. Now, again, just because it has the word geometry does not imply you can only use it in geometry class. I mean, it's common sense. We know that. But again, just to mention. So, but if you just go ahead and start playing with it, right? Remember the circle tool was not actually in the geometry. It was not in the graphing calculator, but it is here, right? And in fact, we could play with the polygon tool. If any of you teachers have played with Geometry Sketchpad in the years past, I used that program for years. I loved it, and I still love it. Okay, I'll turn the tool off. You could do a lot of things here. All right, this app is an awesome app for elementary school students and also middle, especially for elementary, upper and lower, because look at this. If you go to the algebra view, notice that you don't see any numbers. You see verbal descriptions here. The default display for the GeoGebra's geometry app is a verbal description, or what we could call a qualitative description, versus a quantitative descriptor. Okay, but I could show quantitative descriptors if I want to. I'll show you that in a second. But point is, here's what we have. Okay, now I'm going to delete my circles right here and the points. And so right here, let's actually quickly measure the angles of this triangle and add them up and make sure we get 180. All right. That's now I had, regardless of students' levels, I always had them building it in Sketchpad, building it, and we did it on paper as well. Rip off the angles and see, again, many ways to, hands-on. But right here, right, let's hit the word more. And don't feel like you're drowning, please, because that's actually not all of them. There's even another more right down here. You have to hit it 3 times. But notice how these tools are classified, if you will. You see, in GeoGebra's geometry app, you can plot midpoints and centers. You can create perpendicular lines at 2 clicks, you're done. You can make a perpendicular bisector, a parallel line. You see, this functionality would not be allowed on many high stakes exams on states in the United States. The Regents exam in New York, for example, is a classic example, right? The Regents board would never allow, does not currently allow these geometric construction features on the test. And so therefore the GeoGebra graphic calculator totally meets the standards of the Regents boards for the state of New York, for example. Again, just one example, but the geometry app obviously would not, okay? But right here, let's go to the angle tool. It's under measure. All right, we go to angle and just click inside here. That's all you need. And we could actually turn the tool off by dragging the arrow. Now, these are pretty small, I think. So I'm going to go to the settings here. Set the settings gear, settings. The settings one more time. Let's make the font size pretty big so you can see my screen nicely. That's a lot better, yeah. Rounding is 1 decimal place, but again, so what? It's okay. So there we go. Now let's actually, you remember in Geometry Sketchpad, you just had to go to the calculator, you clicked on the angles and boom, it said 180, right? For those of you in the YouTube chat, we're kind of typing it in here. So, but right here, what you can do is see how GeoGebra named them alpha, beta, and gamma, right? So we could use the calculator. It actually is right down here. In the graphing calculator, the buttons appear automatically, but in the geometry app, more people want to build first before calculate, so it kind of hides it. But you click right down here, it'll show up. And now, yes, I know these angles in GeoGebra are labeled with Greek letters, but my logic is, look, if there's a lot of high school kids and middle school kids that figure out how to go around firewalls in schools and get on websites and school blocks, those same students can learn a little bit of Greek, right? So you go over here, and the Greek letters are right here. Whoops, sorry, sorry about that. It's in the alpha, beta, gamma section here. And just like alpha is like where A is, so alpha, right? Plus beta, plus, and then gamma right here, right in the middle. See, alpha plus beta plus gamma, and then enter. There's my 180. But now, just like we used to do in Sketchpad and other apps, perhaps, again, you see the 180 right there. Okay. Yes. To answer your question, Jenny, again, I apologize if I'm not seeing all the comments here as I'm going. I see everyone here and there, but I could save this resource. Yes. All right. Absolutely. And so let's suppose I'm a student in your class and I want to send you my work. This is my work here, and I see it here, right? It is 180 there. But so what I do now, I could make a text box if I wanted to. I could show you the text here, but so see how ABC text? I could say, hey, I discovered some of the measures of the interior angles of a triangle is, now I could actually go here to advanced. Now, again, students could just type it in, but if I actually go to the GeoGebra logo, it's a little right there. And let me go back here. You see how GeoGebra called this delta? It's a brand new Greek letter. If I type in the delta right here, right, and then okay, and I have it right here. See that sum is constant. But you know what? I don't really, whoops, make a new text here. I got to turn the text tool off. But see, I don't really need to type that text. I mean, you can have students type it, but if I see the 180, I know my students have it. So to save this construction, go over here, save, and I'm going to call this triangle angle sum. Okay. Again, you have to have a GeoGebra account to do this. If you don't, GeoGebra is going to prompt you to sign in or create one on the spot. All right. So you hit save. Save successfully. I can hit share right here, or I could just go to the or I could go to the share icon right up here. I go to share. Whenever you share, it saves it anyway. You hit copy. And then that URL I could submit to my teacher in Google Classroom, Schoology, name your LMS, however your students submit it, doesn't matter. If I gave you that URL, you'd be able to access this file as it is. Yeah, Luke, to answer your question with the text box there, I honestly don't know. But if I hit return, let's see if this works. Again, I didn't do much with, yeah. So you just have to hit return right now. In other versions of GeoGebra, it doesn't happen, but again, granted, we know the kids aren't writing a novel here, but yeah, I get it. So just have to hit return if you want to kind of not make it so long, if that makes sense. I totally get it. All right. So right here, I save it. And now if I ever want to go back to that construction the next day, what I would do, let me actually exit out of this. Let me actually exit out of this window, show you how to retrieve it after. Let me just do this. So I exit out of that. I leave. Okay. Hey, Tim, where do I find the resource I just made? My kids are coming to class the next day. That's a great question. You have your students go to their profile. Okay, right here, your profile is where your personal stuff is stored. Okay. Now, see how the latest one here is called triangle angle sum. It's what I saved, right? But what I need to do in order to work on it is click on the three dots and hit open an app. If you click on just the thumbnail right here, it's actually going to take you to what we call like a view only version of it. See, I see how there's no keyboard. I can't really edit it. This is like a Google Doc you only have view access to and you can't do anything with, right? But what I need to do is go to the three dots, go to open an app, and this is going to take me right to where I left off. And now let's suppose I just do something quite different there. And now I made a brand new say, I did something else, and now I want to go back and say, okay, well, you know what? I'm going to, let me see here. I'm going to save it again. I have a choice. I could save it with the same name or save it as something different. If you call it the same name, GeoGebra will overwrite the old file with the new. But if you call it something different, as I did just here, and hit save, watch the URL. It'll change the letters and give it a brand new ID. See, it just changed. And now, if I share that, it'll be an updated version, if you will. Copy it and submit it to my teacher or give it to whomever. All right. There you go. But that's just the basics of the basics. I mean, there's so much more. I mean, like it's already 9:45 already almost, but 15 minutes to go. And I'm going to respect the time. But I'm going to refresh this here. I want to show you some cool things you can discover with this. By the way, just to let you, let me go back to a blank geometry here. All right. Just to let you know, you can show like you can actually show the axes here. There is a coordinate plane here. If I just show the grid, I want to show major grid lines and turn on the axes, there they are. Okay, so we could do a lot of algebra in here as well. Let me just, there we go. All right, I didn't say the settings before. So now let's actually just talk about a couple things. I'm actually going to hide the axes first. I'm going to show you quickly how you can have students use this app to discover parallel lines have the same slope and perpendicular lines have slopes that are opposite reciprocals. Again, oftentimes we as teachers, we feel like we're so pressed for time, and we often are. You are. And so but we could still have students discover within a 5 to 7 minute block, and or maybe for many cases rediscover what you should have remembered from a few weeks ago or from last year, right? So let's actually make a line. It's under the line right here. It's under basic. Once you hit more, I think I hit more 3 times. Show everything. Did I? No, I didn't. Let's hit more one more time. This is everything. And this is why the GeoGebra Classic app has, caused anxiety in some teachers, because all the tools are popping out at you and jumping at you at once. Teachers kind of like the fact that, hey, I like, just give me only the basics, what I need, right here. And then I'll throw in more when I need it. Okay. So we can go ahead and make a line here under basics like that. And let's make a line parallel right here. The parallel line tool is under the construct category. Now, select the line and just plot it anywhere you want. There you go. And don't forget to turn the tool, and don't forget to turn the tool off by hitting the blue arrow. Right? But notice here I can change a lot of things here. And so what do I want students to do? Rediscover parallel lines have the same slope. So just click on the slope and touch the line. There you go. And turn the tool off. And then I ask students, gee, what do you notice? What do you want? Oh, the slopes are always the same. Whoops. If the lines are vertical, what does it say? Oh, it says the slope of a vertical line is undefined. That makes sense. It should be, right? Now, if we throw perpendiculars in the mix, some of you teachers are thinking, Tim, if the slope is shown as if the slope triangle is shown as if the rise of the slope triangle is shown as a decimal approximation, how are the students going to know that they're opposite reciprocals? That's good thinking, because I get asked that question all the time. But let's actually make the perpendicular now. It's under perpendicular line right here, under the construct menu. Susan, it might be the saving. I'm not sure. Send me an email, tim@geogebra.org. If you give me more details, I can help you troubleshoot. All right. tim@geogebra.org. So we go to perpendicular line, and we touch on the line here. We could touch any point we want. And let's get the slope of that tool. Hit the slope tool. There we go. Right? And move it. Now, yes, these are obviously approximations here. But what I can also do, teachers ask me, where's like the math frac button, like the buttons they have to get a fraction, whatever. But right here, if we actually type in the command fraction text, and again, I have to teach students this. They learn how to use GeoGebra. It's not difficult for them. It really isn't. If I do fraction text, I'll just say M, right? See how GeoGebra called M the slope? Yes, Susan, that is correct. Yep. If M is the slope, right? Fraction text M, see how the 5/9 just popped up right there? And now I know that's the slope of this line right here. Okay, now granted, it's approximation here. And I could actually revamp this and make this better if I wanted to. If I go to the settings, go to settings one more time, or go to go to settings one more time and go to the tab that says grid. Settings, hit the settings gear, go to grid. And where it says point capturing, I want to hit fix to grid. So for teachers that have students, where you want to keep things as where you want to keep like, integer coordinates, say, for example, this is kind of a way to keep that fraction looking nice, if you will. See how A, B, and C are forced to be at lattice points? And now I'll do the same thing. I'm actually going to go here and duplicate the command, fraction text of M, and then there's an underscore right here, M_1. Underscore is shift and then the dash there, score 1, and then enter. I'm sorry, I did the wrong one. I meant M_2. Delete that. Duplicate M_2, -8/3. There you go. And so now I move these around. And so students will come in with an activity. I'll say, you know what? I give them maybe 5 or 6 slopes here. Another column, slope of the parallel line, slope of the perpendicular line. and they just have to gather data for a few minutes. And oh my gosh, what do you know? What do you notice? And then, or what did you rediscover? Oh, and then their students are the ones telling me, not me telling them. All right. Now, I used to do the same discovery lesson with paper folding, but students folding perpendicular bisectors point to point, it gets really messy. But something like this, they can't really go wrong. All right. So it's fun. Yes, the app is totally free. And so again, provided you have the device, of course. But let's actually do a little bit more playing in geometry here. Let's talk about some transformational geometry. All right. Now, I realize I have 10 minutes left. There's definitely going to be a part 2 to this. I promise you that. Part 2 will be in probably 2 weeks from now. That's 2 or 3 weeks. So that'll be either the first Wednesday of May or the second Wednesday of May. But I'll have GeoGebra post on their social media when that exact date will be. But it will be a Wednesday. I promise you that. But let's actually have a little fun. Let's bring Odie into the mix. Yeah. There he is. Again, you could drag images in here too. All right. And let's actually go ahead and put on the grid again. Let's put on the axes. Let's put on the grid. Right. And kind of go at it that way. So Odie's here. And now we could talk about, we could actually go ahead and literally talk about transformational geometry. So let's first talk about translation by vector. Popular one, easiest one, I would think, right? Right here, we could actually go and make let's actually plot a point at the origin. We'll plot a point here first. Turn it off. Now I'll move point C right over here. Okay. Let me actually, I'm going to turn on the value here. Turn on the value here. Here we go. And so I've had students get pictures of it, and they find appropriate pictures on the internet. They could take pictures of themselves even, whatever. But I like to make large points movable, make them large. But regardless here, I want to actually take Odie, rotate them, reflect them, dilate, do all that. I'm going to show you how. And it's done right here. Your transformational geometry palette is all right here. You could translate by vectors, rotate around points, reflect about lines, again, reflect about points, and we could dilate, okay? There are also others too. There's a reflect about circle. We can get to that next time. But right here, let's actually, first let's make a vector, which is up here somewhere. It's under lines. Students and teachers, when they start playing with GeoGebra, they spend more time looking for tools than they actually use them. Only for the first 1 or 2 days. Once 2 days it takes, you know where everything is. I promise you that. Okay. But let's make a vector anywhere in the coordinate plane, start point, end point, right? And so now, if I want to translate by vector, right, what do I have to highlight it? I lasso everything I want to translate. I want to translate Odie in the 2 points. So I see how I just highlighted in there. I select everything I want to translate, and then I select the vector. And of course, I turn the tool off by hitting the arrow. And look at that. There he is. And so let's actually show the components of the vector here. All right, we'll show the value. We'll make it a nicer color, make it thicker. Who knows? You do what you want. Point is, you know what? You could do anything. So you can ask students. You can have students tell you typical, questions we often tell them. What vector maps Odie onto himself? Okay, well, that's pretty obvious now, right? 0, 0, and moving whatever. And so students can, from playing with this, they can generate that G, a point A comma B under a vector with components X comma Y has images of, so again, it's all about putting the student at the center, not you. All right. Let's actually rotate Odie while we're at it, if you don't mind. Let me go hide. Let me just make them fade away. Nothing right there. There we go. I'm just going to delete that for now. I'll delete it. So let's actually rotate Odie and see what happens. So we do the same thing. So we go to rotate around point right here. And so now we could take Odie, drag everything we need. We're going to rotate him about C now. But, and actually, you know what I'm going to do first? I forgot to do something. I like to make a slider. I have had students make sliders all the time. Type in, let's say let's say K equals 0 degrees. Because I'm too lazy to find the degree symbol in the keyboard, I just like to type DEG. And what it does is it actually makes a slider for you, 0 to 360. It's really, really sweet. Okay. So now let's rotate Odie again. Okay. So let's go here. We'll go to rotate around point right there. And then we can just lasso Odie in A and B. And then I'll choose points. I have to select the rotation point next, that's C. And then instead of actually typing in a number, I'm going to call it K because I want to control where Odie goes. And then I turn the tool off and see here, I can rotate Odie how I want. Let's actually fade him out a little bit. And so teachers, instead of telling students, hey, if a point rotates about the origin under 90 degrees, right, let's have them tell us what, let's have them tell us what happens. Stop right there. Or I could also just type it in too, you know, but gee, 3, 1 gets rotated to -1, 3. 5, 3 goes to -3, 5. What do you notice? Oh, and again, they could go ahead and just see the dynamics of what happens here. You see what I mean? And so they could see Odie and see what happens as we go through, right? Pretty neat. I'll end it with a reflection, but instead, this is kind of I don't know how well this is going to work. I did it a little bit before, but we're going to continue with this next time and talk about some other real world examples we could play here and have kids discover within this app. But let me actually get rid of the axes and the grid, and let's delete the vector. And I would often, sometimes I've had students take a picture of their face, and I actually took a picture of half my face before. Let me see here, kind of zoom out a little bit. Now, I feel kind of embarrassed doing it this way, but what would it look like if your face was perfectly symmetrical, right? I mean, it'd be kind of interesting to see, well, you know what, you know, this is the half, what would the other half look like? I mean, the other part is like right here, right? Sorry about that, let me just hide that, there we go. But now, right, we could actually, now I wanna actually reflect that half image right here about that vertical crease there. So, but before I do that, I actually just took a selfie on a phone, I sent it to the computer pretty much, and then just kind of used whatever preview. I kind of chopped it in half. Again, I am not a photographer by any means, but right here, one thing I could tell GeoGebra to do is to rotate. I'm going to rotate point B 90 degrees about A, right? I could have used the tool to do it, but I could also type it in as well. Rotate point B, the right corner, 90 degrees about the lower left corner, which is A. And so there it is. And so now we can actually make a line here, AB. Because in order to reflect in GeoGebra, reflect about a line, we need a line, right? And so right here, let's actually do just that. We could use the reflect about line tool. Select what you want to reflect, select the line, and there you go. And that picture kind of freaks me out. It really does. I mean, if any of you, I think there's apps that do it too, but to actually see what your face looks like, if you actually could, if your face was perfectly symmetrical right down the middle. But again, you know, bottom line is it's just it's kind of interesting to see what goes on. But you can reflect anything about anything and still get, and then you can actually fade it a little bit and compare. Students could try to compare and see, gosh, what would my face look like? And they could send it to you, try to put this over it. It's not the same thing, face morph, if you will, but I don't know. But see how like our faces are not symmetrical by any means. So there you have it. And that in and of itself concludes, we're pretty much out of time here right now. So that's part 1 of exploring GeoGebra Graphing Calculator and Geometry app. We'll continue with part 2 on a Wednesday night in May. Not quite sure the date, but I promise I will put it on social media as soon as I do know. And so, yeah, 10 o'clock. So thank you so much.